Imagine a system where you can hit a button and you can put drones anywhere on Earth in an hour. You could put 1 million drones. And this really forces us to rethink the way the $1 trillion defense budget is being deployed. I think in the last 5 years, we've seen commercial space dominate geopolitics. Space is a place where we can connect anything, see anything, coordinate anything. I think the geopolitical implications of this are that every country will want to have sovereign access to space.
Chris is the founder, chairman, and CEO of Astra. Astra has been the fastest company to deploy satellites into the Earth's orbit. It's a leading supplier of satellite engines. Chris also has served as the CTO of NASA, also founded OpenStack, the largest and fastest growing open source project in history. And while at NASA, he also worked at the White House to develop the cloud computing strategy for the US government.
When I joined NASA, I remember bringing colleagues of mine from tech companies in the Bay Area to go see space shuttle launches. And one of the things that struck me was just how much cost and energy went into a space shuttle launch. And I just said, wow, what if every time an airplane took off, there was a party with 10,000 people? This is why the space shuttle was so expensive. I think it's just how quickly and how much the space industry is growing. It's faster than almost any other sector. The model that we've been using for decades was like a Hubble Space Telescope pointed at Earth kind of model, and it cost billions of dollars. We've moved away from that to companies that are building satellites that started out the size of cell phones. Look at SpaceX's valuation. They were a couple $1 billion company, and then a tens of billions, hundreds of billions. It's one of the most valuable private companies in the world.
Where do you see the big categories within the space economy, and where you see the most exciting pieces happening?
I think there's almost an inverse relationship between what people think and what's real. So people think about Lawrence Sanchez and Jeff Bezos taking rides up into space, and Katy Perry. They talk about manufacturing in space. They talk about going to Mars. That is irrelevant. The next step here is to see globally competitive set of constellations that all talk to each other.
No major global competitors there?
Our rockets are mobile. You can pack up the entire spaceport and deploy it in a few days, launch globally. That's a very unique product that the competitors that have attempted this have failed. Virgin Orbit failed with a bankruptcy with their rocket that you could deploy from an aircraft.
What about China?
I would say China is a solid number 2 in terms of number of launches globally, behind SpaceX. Then I would put India there in number 3. These are the very early days of base, and we're going to start to see that really unfold over the next 10 years.
Hi, and welcome to today's episode of the Great Tech Game podcast, where we bring you some of the world's best thinkers, leaders, entrepreneurs, investors, and intellectuals to talk about the intersection of technology, geopolitics, and global affairs. And as part of our ongoing series on space and space technology, I couldn't be more excited to have with us today Chris Kemp. So we're really excited to get a big picture of you and then also dig deep with you today, Chris. So welcome to the Great Tech Game podcast.
Thank you. It's great to be here and on the podcast. I look forward to diving in.
So Chris, I typically start our podcasts with broad, big picture questions. Right now, you've been in the space for a while. Tell us how you have seen over the last, let's say, 3 to 5 years, what have been the key advancements, either technologically or geopolitically, that you would say, okay, these are the 3 or 4 main trends or main developments in the space industry?
I think in the last 5 years, we've seen commercial space dominate geopolitics. It was just a few years ago when we watched as Vladimir Putin denied that he was invading Ukraine, when commercial satellite companies took pictures of tanks, literally while that was happening, rolling across the border and invading Ukraine. And this was not the national intelligence apparatus of the United States or Europe. This was Planet Labs, a commercial satellite company that has a satellite constellation that images the Earth every day. We've seen in Ukraine, Starlink be absolutely instrumental in both the ability for the troops to coordinate and communicate, and also the geopolitical challenges associated with that. When the service was available and not available at times. So I think people have really started to appreciate that space is the ultimate high ground. And like humans have been climbing to the tops of mountains for millennia, building castles, initially radio towers, more recently cell towers, observation towers. Space is the ultimate high ground. So space is a place where we can connect anything. It's a place we can see anything. It's a place we can coordinate anything. And I think the geopolitical implications of this are that every country will want to have sovereign access to space. Every country will want to be able to own, operate, and control their own communications and surveillance infrastructure in space. The technical challenges of this are being solved through technologies like I worked on at NASA and at other companies. When we think of data centers now, we don't think of a single server, just like we don't think of satellites like a single billion-dollar spy satellite. We think about swarms of thousands and maybe millions someday of satellites that will provide a ubiquitous layer of connectivity and sensing around our planet. And that's going to have significant implications to how countries operate and communicate and watch over each other to create a safer world.
Yeah, and tell us, you were, I guess, at NASA now several years ago as a CTO. From the time you've, let's say, entered the space industry to today, how long has that been? How many years are we talking here? From the time
I
when you
joined
entered?
NASA about 20 years ago. So I spent, I believe, 2005 through about 2011. I left NASA to found a company based on some technology I developed at NASA. That company was acquired ultimately by Oracle, and then I started Astra. So it's been about 20 years.
And so over those 20 years, what has shocked you? What has surprised you about how the space industry has evolved?
Well, when I joined NASA, I remember bringing colleagues of mine from tech companies in the Bay Area to go see space shuttle launches. And one of the things that struck me was just how much cost and energy went into a space shuttle launch. We would go and thousands of people would go to Cape Canaveral, and there would be big events where ice sculptures with the Boeing logo or the ATK logo. And I just said, wow, this is crazy. What if every time an airplane took off, there was a party with 10,000 people? And I mean, this is why the space shuttle was so expensive. I was really amazed at how quickly, after SpaceX demonstrated it could deliver cargo to the space station, how quickly they were able to, and generally commercial companies such as Planet were able to really, in relative terms, transform the industry. So, you're sitting in front of a rocket factory here that can produce hundreds of rockets per year. We're making sure that the next rocket we launch not only will be reliable and successful, but large enough to carry all of the satellites that are being developed today. We can produce it on a production line that can produce hundreds of rockets per year. That I can even say that is rather astonishing when I recall where we were when I started at NASA back in 2005. So I think it's just how quickly and how much the space industry is growing. In financial terms, the CAGR is around 15% per year. It's faster than almost any other sector. You've seen, however you want to measure it. Look at SpaceX's valuation. They were a couple $1 billion company, and then at tens of billions, hundreds of billions of. It's one of the most valuable private companies in the world. So just how much value is created. I have a Starlink. It's amazing. The ability to connect from anywhere with a little panel this big. We have a customer called AST Space Mobile that's doing deals with AT&T and Verizon. You'll be able to send messages and take calls from your cell phone anywhere on Earth. It's incredible, just the rate of innovation and how quickly this stuff is coming and how fast the market's growing here.
Yeah. Has anything surprised you about why something has not changed? Some things that have not changed that you would have expected to have changed in this period?
Yeah, I think there's still so much money going into the old way of doing things. You look at the number of the many billions of dollars that still that the DoD is still flowing into the primes and the big $1 billion satellites. Obviously, they have a purpose, but it is quite obvious that a satellite in low Earth orbit can take a pretty good picture of something relative to a satellite tens of thousands of miles away from the planet. There's two ways to get a better picture. You can get your camera closer to the subject, or you can get a really big telephoto lens. And I think the model that we've been using for decades was just a really like a Hubble Space Telescope pointed at Earth kind of model. And they cost billions of dollars. And we've moved away from that to companies that are building satellites that started out the size of cell phones, but are in a very low orbit. And I don't know about your iPhone. I mean, iPhones are amazing. You can the quality of the imaging devices available today surpasses surveillance satellites from 10, 15 years ago.
Yeah. Give us a quick, before we dig into your work at Astra, give us your quick overview of the space economy, right? Where do you see the big categories within the space economy, and where you see the most exciting pieces happening, where you feel like, as you're saying, that we'll end up seeing a lot of innovation, or we'll end up seeing a lot of value creation? What are those different big categories that you see within the space umbrella?
Yeah, I think there's almost an inverse relationship between what people think and what's real. So people think about, Lawrence Sanchez and Jeff Bezos taking rides up into space, and Katy Perry, and they talk about manufacturing in space. They talk about going to Mars. That is nothing. That is irrelevant. That is in terms of the overall value of the economic impact and the value financially of space tourism. It's almost zero. I mean, it's a rounding error. Where the value is in things that people don't even really think about, like communications. So the ability to provide connectivity, whether it's on airplanes or to cellular towers for backhaul, or directly to consumers via services like Starlink. That's what's driving the value in companies like SpaceX, is this global ubiquitous connectivity. And if there's another one, it's observing the planet. And we're starting to see more of that as we have a better sense of what's going on, but not just visually inspecting what's happening, but doing it in different wavelengths. So understanding the health of crops by looking at hyperspectral imaging. And I think that as we start to appreciate the economic value of these things, you're going to go from having just a few companies doing this to having really a much more distributed set of competitive companies globally doing this. So it's not just going to be U.S. companies. I like to think about Starlink through the lens of the early days of the internet, when you had AOL and maybe Kuiper's CompuServe, where you have totally closed, vertically integrated systems that are owned and operated by one company. And that's how you start things. But ultimately, in the end, there was the internet, right, where you had many tens of thousands of networks that all connect together. And I think that there will be, we're going to put the internet in space, right? And that's the next step here, is to see a globally competitive, highly distributed and resilient set of constellations that all talk to each other. And I think we're really just getting started there. So I think these are the very early days of the space internet. And we're going to start to see that really unfold over the next 10 years.
Yeah. No, that's great. I think you've laid out something that I'm hoping we'll come back to actually and dig deeper about the future of space in a way. But let's dig deep into your journey at Astra now, Chris. You've had several years of this journey at Astra with ups and downs. Talk to us about some of the key highlights of that journey so far.
Yeah, well, I think I like to say we're just getting started. Relative to other companies, I think you noted we put satellites in orbit faster than any company or really any team in history. The company just celebrated its 8th birthday. And by contrast, companies like SpaceX and Rocket Lab have been around for over 20 years. And so I think we're very early in this. We've made an enormous amount of progress with multiple successful orbital launches, with the 3rd generation of our rocket. Really, the big thing that happened there wasn't that we didn't have enough reliable or successful launches. We had the wrong product for the market, because the market evolved. Back when I started Astra, back at the end of 16, early 2017, I looked at the market and I saw a lot of satellites the size of the loaves of bread, right? So little satellites like the Dove satellite from Planet. There weren't Starlink class satellites, right? And Starlink, the first generation of Starlink satellites were coming in at over a couple of 100 kilograms. They've gotten bigger. So satellites have gotten bigger, right? So companies have realized they want bigger satellites with higher resolution images, with more bandwidth, more capacity. And so what we've started to see now is a number of constellations deploy satellites that are more around 500 kilograms. And so our previous rocket, which it's kind of off screen here, you can't really see it, could maybe deploy a group of satellites that weighed up to 50 or 60 kilograms, maybe 100 if we really put a lot of energy into refining the rocket. But the rocket was very small, and the problem is if you can only ever maybe throw a maximum of 100
That's
kilograms.
The one that's part open right now?
This one is the new Rocket 4 fairing. So I don't know if you can see the... Yeah, maybe
I can see the one on the edge.
Yeah. Oh, you can. Yeah, that's Rocket 3. So that's great, actually. So you can see the difference between Rocket 3 and Rocket 4. So you could probably put a very large refrigerator in Rocket 4's fairing, or maybe a small, like a golf cart kind of size satellite. So it's a much larger, it's over 100 times the volume, and at least 10 times the mass. So our initial flights of Rocket 4 will do 600 to 700 kilograms, and then we'll go up to over 1,000 kilograms per launch with the new rocket. And so, one of the things that I learned was we did Rocket 1, then we did Rocket 2, then we did Rocket 3, then we did Rocket 4. So we've had 4 generations of rockets in a time scale that most companies barely get one done. And that was a little too fast. And so we really, we took our time in this latest generation because we realized that there's making a rocket work once, probably one of the hardest things to do. Many countries haven't yet cracked this. Once you make it work once, having the next 10 also work is a completely different problem, right? That's a problem of supplier quality and reliability engineering and the rigor that you've used in your manufacturing process to ensure that all of the rockets are exactly the same. Because if there are any differences, or if you're unable to ensure that you have enough margin spread around, then an in-flight condition that doesn't affect a launch might affect the next launch. And so you really have, you have to put an enormous amount of rigor all the way up front when you look at your initial understanding of potential failures and their effects, and you think about how you're testing it and providing test coverage so there's no quality escapes. And honestly, it sounds really boring, but having a rocket work once and having a rocket work hundreds of times with very high reliability are very different problems. Now, one of the things that we did when we went public was we bought a company called Apollo Fusion. They had a very exciting space propulsion technology that had never been tested when we bought the company. One worked shortly after our acquisition, which was great. It continued to work for 3 years on orbit, which was even better. We have now sold hundreds of these engines, and we shipped 42 of them last quarter. We intend to ship at least that many this quarter. And this is, I believe, the best-selling, most highly produced engine. It's being used by many of the satellites that launch on a Falcon 9 rocket from the rideshare missions. So this product has been really great for us because it's been the cash flow from this product. I've invested every penny back into bringing Rocket 4 back to the pad. So we've been running our company more or less cash flow neutral and EBITDA neutral just by reinvesting the revenue and cash from that business back into the rocket. We've had some support from the Defense Department as well, which I appreciate. And but it's also kept us focused on how to manufacture a high quality product. Right? So it's the systems that allow you to understand how to manage your suppliers and supplier quality. It's inventory systems. This is a fairly complex product in a lot of different configurations. So it's allowed me to really maintain a level of rigor around production and a mentality around manufacturing at the company for the past few years. And this is going to be essential when the first Rocket 4 flight is successful for us to transition it quickly into production and ramp the number of launches and the rate. I can have a factory that can produce hundreds of rockets a year, but can I have a company that can do that reliably and consistently? And I've really been focused on that for the last few years. And not having the distraction of being a public company has been very helpful. I took the company private last summer. I don't think a founder has ever taken a company public before without a private equity shop coming in and taking control. Michael Dell did this with Silver Lake, but I led the first founder-led take private of a company without private equity, I believe, in the history of corporate America. And that was hard, but it just shows how much passion the team and we have for our customers. We needed to ensure the company could operate and deliver for our customers, regardless of what happened in financial markets.
Talk to me about within the US, of course, but then maybe even globally, key competitors now for the kind of work you're doing. This vision that you have of producing hundreds of rockets from a factory, like I think you've said in other places, like almost like a car factory, right? Is the vision. Who's competition for you, and who's let's say complementary to you, and who's customer for you?
Yeah, I think the way I like to look at the market right now is there are a couple of companies that are competing for in a very large launch space, right? So if you're deploying large mega constellations as the primary deployment mechanism, we're not competing with that, right? I mean, our rockets are mobile. You can pack them up into shipping containers and ship them. You can pack up the entire spaceport and deploy it in a few days, launch globally. That's a very unique product that, frankly, the competitors that have attempted this have failed. Virgin Orbit failed with a bankruptcy with their rocket that you could deploy from an aircraft. A company called ABL, no longer doing that, pivoted. And a company called Relativity has pivoted to focus on a much larger rocket, many times the size of a Falcon 9. So I don't like to think of Astra as competing with these large rockets. I like to think of Astra as a segment of the market that I think is really exciting as we look at new things the government's trying to do with Golden Dome, as we look at all the diversity of competition where you have new companies that they need to go and put a satellite on a specific orbit and on a specific time. They're not going to wait a couple of years to get dropped off in the wrong place. It's like a bus. Does a bus compete with an Uber? A little bit, but not really. Like I didn't consider taking a bus to work because it would have taken hours versus I can just get in a car and an Uber and I'm here in minutes. So I think that's how I like to look at that. The scoreboard really, if you look just launch in general, space in general, you've got SpaceX, which is an incredibly impressive company. They've done over 500 launches. You have a company called Rocket Lab that is, I think, over 50 now launches, but that's an order of magnitude difference solidly in the number 2 slot there. We've done 2 successful launches out of 4 attempts for commercial launches. Another company called Firefly, also 2 successful launches out of, I believe, 6 attempts. That's pretty good, but that's 1, 2, 3, 4. And then I think Blue Origin has another large rocket that has successfully launched once and delivered, gotten to orbit on the first try. Very impressive, but a much larger rocket. So that's it in terms of companies building orbital rockets that have had successful orbital launches where satellites have been deployed or the rockets have reached orbit.
No major global competitors there?
Well, I mean, there's a number of European companies that have tried to build rockets, and I'm talking about commercial companies, not nation states. Like the European Space Agency obviously has rockets, like the Ariane 6 that they're building. But these are, it's kind of like ULA. It's a highly government subsidized commercial hybrid kind of company. They're not pure commercial companies.
What about China?
Yeah, I mean, obviously China. I think China and India, I would say, appreciating the global reach of your audience here. But I would say China is a solid number 2 in terms of number of launches globally behind SpaceX. And then I would put India there in number 3. They have ISRO and they have a PSLV vehicle. They've been working on a new smaller vehicle called SSLV that I don't believe has successfully operated, but I could be wrong on that. But generally, countries want to maintain the sovereign access to space. And right now they're having to go through their allies. So there are countries that are more aligned with the U.S. that generally favor U.S. launches. U.S. satellites generally do not launch on Chinese rockets, nor do European satellites. And so a lot of European satellites will pick between launching on a U.S. vehicle or on a European vehicle based on. But these are, think about a launch. The cost of a single launch, still, I think a Falcon 9 launch is around $75 million. And other vehicles cost north of $100 million per launch. So again, back to Astra, we're focused on a $5 million launch that we can operate from anywhere. And that's a very different capability.
Yeah. Let's move into the public-private aspects of space, right? I think the 20-odd years that you've been in the space industry, Chris, I think you've probably seen this shift very closely from a much more nation-state, national space agency guarded sector to where now the private sector is increasingly being seen as maybe almost the engine of growth, right? More so than the space agencies themselves. As a company, you've mentioned, of course, that you are working with a whole range of clients. You have both government and private companies as clients. Tell me how different are those clients from from where you sit, the needs, the requirements, the concerns, and how have you navigated those two different sets of clients in a way?
It's a great question, actually. And I would say they couldn't be more different. And I would say we were not very good at navigating that. We saw a product like I'll use our satellite engine product as a good example. We saw it successfully adopted by commercial companies. A lot of the new satellite companies that are commercially oriented bought the product. They incorporated the product in their satellites. They're on orbit. They're working great. And then you had some of the government programs that really tried to manage this thing like it was $1 billion satellite, right? So if you look at the companies like SpaceX, they're building thousands of satellites. Planet's building hundreds of satellites. Northrop Grumman, Lockheed Martin, L3 Harris, the typical government primes, they're just not set up to make a satellite for $1 million. They're set up to make a satellite for $1 billion. And so just the way they think about mission assurance and managing a program like that, we'd have meetings where 50 people would be in the room. This is for a product that they were trying to buy for a few $100,000, not a few $100 million. And so there was a real impedance mismatch there, where they wanted the low prices that they were seeing in the commercial sector, but they didn't know how to structure contracts or run programs that didn't just crush all the companies that were trying to partner with them. And so we saw a wave of companies that really financially struggled. Companies like Terran Orbital took on an enormous amount of debt as public companies, basically were acquired by the primes. And it was a real challenge. I'm not embedded in any of these companies, but I watched Virgin Orbit likely struggle with the mission assurance requirements associated with having the government as a launch customer. We see it. We have a lot of conversations internally and with our government customers about how much is an appropriate amount of energy to put into a program that you want to have these launches cost a few $1 million. The way to make sure they cost $100 million like everyone else is to make the Astra have to have thousands of employees to impedance match with the government on some of these programs. So it's tricky. I really respect what SpaceX has done in this area, where they focused on just incredibly great engineering and building a very compelling product and doing it on their terms. And they say, if the government wants to buy it, great. If they don't, fine. It's the right approach, really. If you want to see innovation happen, you can't manage it like yesterday's programs.
Yeah. You mentioned, of course, the Golden Dome project that the U.S. is planning. Talk to us about the defense tech implications, the work you're doing with the government, and how it fits into maybe a more macro geopolitical picture today.
Yeah, this is something I'm really excited about. First, we were awarded a contract recently from the Department of Defense to demonstrate putting drones in a rocket and delivering them to the other side of the planet in about 45 minutes. And if you really think about the implications of that, you look
And
at
this
other.
rocket, I mean, describe to us. So
Yeah.
how would this work?
Yeah, so imagine something's happening on the other side of the planet, and you want to put drones there. How do you do that today? Well, you probably need to fly a Navy SEAL team there from some Air Force base, and so you basically have to activate a global logistics infrastructure to, and hopefully you control the airspace, or you can protect the airspace so that you can kind of get your drones where they need to be. We saw recently some drones in the Russia-Ukraine conflict destroy a number of the strategic bomber fleet in Russia. They had to drive those across the border and plant them so that the drones could effectively hatch and attack those. Imagine if those drones were positioned anywhere on Earth, and they could be anywhere else on Earth in about an hour. And then imagine scaling that. So imagine having millions of drones in thousands of rockets that are in hundreds of locations. And you say, well, that's kind of crazy. No, look at the Patriot missile system, for example. Everybody talks about how the Patriot missile system is protecting our allies and our own assets. Well, the Patriot missile system, I believe there are about 1,300 Patriot missile launchers that are typically organized in batteries of 4 to 8 launchers. You have a number of Patriot missiles that are stockpiled in these batteries, and those are located in, I believe, about 18 different countries. And so these are our allies that we're protecting. Imagine a system where Astra rockets are positioned in 18 different countries, and you have millions of drones in thousands of rockets in these hundreds of locations in dozens of countries. And now you can hit a button and you can put drones anywhere on Earth in an hour. You could put 1 million drones, or 100,000 drones. And I think that this really forces us to rethink the way the $1 trillion defense budget is being deployed. Because right now, unlike China, China has really largely built their fleet of aircraft carriers and their fleet of fighter jets. We have been doing this for 100 years. So we have a lot of older infrastructure. So a significant portion of our defense budget goes to O&M, which is another way of saying just operating and maintaining the stuff that we have, which is largely aging. Yeah. So and I think if we were to just click a button and say reset, our military would look very different. And I think there would be more rockets, more AI drones, and satellites in that future of version of our military.
And so where are you on this project now? This is a pilot thing that you're going to start working on, or is this something that's a few years away? How are you thinking about this project that you're starting to work on?
It leverages this new rocket. So
Rocket 4?
Yeah, Rocket 4. Yep. So what it will do, we will have a partner that supplies the drones, and they'll be just standard commercial drones that are otherwise being used on the battlefield. And then we'll have a reentry vehicle. We're in the process of competing that, and that will take the drones from orbit. So our rocket will launch. It might go into orbit, and then it will deploy a reentry vehicle. That reentry vehicle can probably do a maneuver where it can go somewhere very different than where the orbit is. So the rocket launch will not look like a ballistic attack on another country. It'll look like an orbital rocket launch. And then that reentry vehicle can deploy the drones at an operational altitude where they can conduct a mission. And so it'll be an end-to-end delivery demonstration of this capability.
And as you're working, let's say, with the Defense Department, with the DIU, we've seen over the last 2 years the Silicon Valley and Pentagon relationship become quite close, right? We've had guests like, I think earlier on the podcast, like Lieutenant General Jack Shanahan, who are heading Project Maven and the Joint AI Center at the Pentagon. We've had some venture capitalists from Silicon Valley, from firms like Shield Capital, who are talking about how close that interaction has become. Where do you see that relationship headed? Is it largely going to be the same way it's been going now, which is that of collaboration and almost on this national mission to make both Pentagon a lot more future ready, but then also leverage Silicon Valley strength? Or do you expect there to be tensions?
Well, I mean, I think there's always been a very close connection. You look at the very early days of the internet, and it's started out as an advanced defense
Okay.
research project.
That's right. DARPA-led project, yeah.
Yeah, and I think that you look at the investments that a lot of the DoD entities are making in Astra, and they see the capability that we're developing, and there's always Silicon Valley is great because we have this fantastic combination of national labs, and you've got Berkeley and Stanford and Livermore. You've got a lot of investments there, and then you've got Sand Hill Road. You've got some of the largest sources of capital to fund stuff, and then you've got folks like NASA. You've got NASA Ames Research Center, and you've got the Defense Innovation Unit down in Mountain View, which directs a lot of funding to projects that are important. And then you've got all the entrepreneurs here and all the tech startups. And I think we went through a period where there were some missteps by tech companies that caused there to be a lot of negative PR associated with serving your country with technology. And I think that most companies have to think about how they have a commercial focus and they have a defense focus. And I mean, you look at any airplane, you can use an airplane to put commercial passengers somewhere, and you can use a commercial airplane. It's not like the Defense Department moves troops around on custom airplanes. I mean, the airplane's an airplane, a rocket's a rocket, right? So I think we think about this from the perspective of how do we protect our country, and how do we, and our mission statement is improve life on Earth from space by creating a safer and more connected planet. So there's an aspect of safety. I view our defense focus creating a safer planet, making sure we have a capability that is a deterrent. If I'm China, I'm not going to attack a country that can put hundreds of put thousands of rockets in hundreds of locations. But right now we're in a very fragile state. We have 2 spaceports, maybe 3 if you count where Starship is launched in Brownsville, but 4 or 5 if you count where we launch out of in Alaska or in Wallops. But what if we only had a handful of airports? We're an earthquake and a hurricane away from not being able to reach space. And so this is an invitation, right, to take advantage of our weakness. So if we can, as a country, just like we're putting thousands of satellites, if we can have hundreds of locations where we can launch from that we have control over, it really just it makes the world a safer place, which seems a bit antithetical, but it's true, right? If you make it so that the attack won't succeed, then you prevent the attack.
That's right. One of the other aspects of this, of course, is as space companies come up everywhere, private space companies come up across the world. Well, of course, the US being the leading nation in this, you'll find that companies like yours are also going to work with other foreign governments. Companies based elsewhere might be working with the US Space Force. In peacetime, this, of course, works beautifully, right? And one of the things I talked about in my own book, The Great Tech Game, was how, for example, telegraph technology, when it comes out over 100, 150 years ago, it's great for communications for everyone, right? But the moment wartime comes, right, in peacetime, every tech seems to be the boon for everyone, right? I mean, efficiency, cost saving, of course, greater capabilities. But then in wartime, it's often those same technologies that then become critical, right? Geopolitically. How do you anticipate in wartime this almost global conglomeration of private space companies working with governments across the world? How do you anticipate that panning out? Is that a real risk of governments finding that somehow certain private companies are not as reliable as they might have been in peacetime, or private companies start to feel much more constrained in who they can work for, who they cannot work for? How do you see this panning out?
Yeah, I think just getting back, it all comes back to economics, right? So if you look at what is the cost of a uh, THAAD missile or something, or even a Patriot missile, and then you look at the cost of a drone. I mean, to some degree, it's if it costs you, $100 million to make a thing, and you can only make 100 of them per year, then that's a problem. If you can basically achieve a similar effect for something that costs $1,000, and if an aircraft parked on the ground that cost $100 million can get taken out with a $500 drone, or if a warship parked in the Gulf can be attacked with a $10,000 explosives loaded up into a drone ship. Well, that asymmetry is the problem, because the adversary can build $10,000 drone ships. They can build 10,000 of them and just send them in every aircraft carrier in the world, and they can certainly build those faster than we can build $15 billion or $13 billion aircraft carriers. So, I think it all comes down to economics and scale. Unfortunately, over the last 30 or 40 years, we have been in peacetime, or maybe fortunately. And from an economic standpoint, though, it's meant that the industrial base has scaled down, and we've got 80% of our manufacturing base. This is an interesting statistic. If you look at the ability to manufacture things in America, the top 20 manufacturers in America represent less than 20% of the overall capacity in the country. Okay, so which means the next 80% of our manufacturing capacity is tens of thousands of small businesses. And so if you tell a Boeing or a Lockheed to go make more of something, and they're sourcing parts, they very well may be sourcing parts from a mom and pop machine shop somewhere that literally just cannot scale the capacity. And if you're building 500 of these missiles per year every year for the past 20 years, likewise, Lockheed or whatever has scaled their production output to that rate, and you can't just go send 10,000 of them to Ukraine and say, hey, we need 10,000 more in 6 months. It just doesn't work that way, right? So, I think we, to some degree, when we started Astra, said we're going to make a rocket a day. And so our mission has always been design the rocket for mass production, and that starts, from the very first whiteboard. It's you don't use carbon fiber, you don't use 3D printing, you don't use labor-intensive manufacturing processes. There is nothing that makes our new rocket anything like Rocket Lab. It is literally everything is different about it. And what's different about it is it's not designed to be reusable. It's not designed to be something that takes a long time to produce. It's designed to be mass produced on a production line like a car, and that's just a fundamentally different set of design constraints. And it's getting back to my previous point. If it takes 5 to 10 years to build a capability like this, more if you have more money, then there is no amount of money that can make a new rocket system come into existence. I would argue that it costs about $1 billion and about 10 years to bring a new rocket system into production operations. And I will cite every rocket company that's ever existed as an example of that. You look at Blue Origin. That effort was started back in the very early 2000s. So they're about 25 years into this project, and I believe most estimates are at least tens of billions of dollars invested. Now, they built a rocket that worked the first time, and that's incredibly impressive. That's a lot like how NASA does things, right? When you don't want it to, like when you absolutely have to have it work the first time, there is a way to do that, but it takes decades and costs tens of billions of dollars. Another way to do that is how we did it, where we got to orbit in 4 years. But maybe that was a little too quick, and we should have put more rigor and energy into failure mode effects analysis and testing and supplier quality. So that wasn't sufficient. Now, the new rocket, what we're trying to do is thread that needle where it can be both affordable and reliable, and also produced at scale. And that's a really tough thing to do. So I think but look at that across every aspect of defense now. We now have aircraft that cost $250 million a piece. And these aircraft are vulnerable to being destroyed with a drone that maybe cost a few $1,000s. That asymmetry is the problem.
So is your vision then that, to my earlier question, that by making things more affordable, building them at scale, mass producing them as you're thinking, the geopolitical risks of working with various governments around the world somehow goes down?
Well,
Or the
and
risks?
I would say that's correct, because if you have, or right now the U.S. operates under this regime of ITAR, which means we can't export rockets. Well, the problem is now that means that we don't have a global market for rockets, right? We have a very protectionist policy. We can't export them. In fact, it's illegal to export rockets. You have to get all this State Department, TAA stuff. I mean, a rocket is a transportation thing. It's also an ICBM. So, it's tricky to manage this. But if you have a policy that says, well, theoretically American companies can buy European rockets, but European companies can't buy American rockets, well, then that effectively reduces the total addressable market for American rockets. Yeah. And so it's all great when you're early in the market, but China's not going to apply a policy like that. So we saw in drones, companies like DJI with significant government subsidies crush all the American drone companies. So you look at the global production of drones, we're going to have some new American companies take runs at this, but the price point of a DJI drone is just ridiculous. You can go to Amazon.com right now, and you can get a drone that has HD video that streams to your iPhone that can do backflips that you can control haptically for $15. That's insane, right? It's because they're making a ton of them, and there's a chip that does all that. It's with little electric motors and everything. It's crazy what scale does. One of my mentors and investors that I really respect once said, "Scale is what makes innovation matter." I think Reid Hoffman said that, and I think that's very prescient, right? You can have something really innovative, but if it isn't,
if you can't scale, correct?
Yeah, and I think that's what happens with a lot of this technology is that you get a really incredible scientist that creates something and they do it once, and then who cares, right? So I think the big idea there is if you're going to innovate and you want to matter, scale it. Another variation of that is there are 3 M's. You have to start a lot of people think, oh, look, I did something cool. I matter. You don't matter, right? You make something. That's step one. A lot of people don't get past the drawing board. They never actually even build the thing. People talk about hundreds of rocket companies. How many actually launch a rocket? It's like 1%.
That's
right?
Yeah.
And then how many of those rockets actually work? Very few. And so the first thing you have to do is you have to make it. You can't just talk about it. And then you have to master it. And I would argue very few ever master anything. They might make it work a few times. But until you truly master something, it doesn't matter. And so that's my kind of rule of 3 M's, make it, master it, then it matters.
Yeah. I think that's great. One of the other things, Chris, that I'd like to talk about as we look into the future, as space becomes a domain for warfare, becomes a very geopolitically contested domain, as we've been discussing, as the world becomes generally a lot more conflictual, right? As you were also mentioning, we'd seen 30, 40 years of peace in a unipolar world, and now we have these intense contestations going on, and space will clearly become a domain where that contestation will play out. Space companies like yours and space assets like the ones you are putting out, other companies are putting out, will also become, in a way, participants in conflict, right? Mm-hmm. And as a result, not just in enabling, let's say, as you were saying, sending rockets that can get drones anywhere across the world in 45 minutes, but also becoming targets themselves. Mm-hmm. Is that something you think about?
Absolutely, yeah. I think that the only way that you can really navigate that is, again, you gotta make it, you gotta master it. But that at the point where you're mastering it, at some point you've got to think of it as a strategic capability that you need to protect. And so if, for example, When this production line starts making hundreds of rockets per year, well, it's a target at that point, right? And because if it becomes something that's critical to national security,
Okay.
and so one thing you could do is you could say, well, Astra can make rockets and spaceports and pack them up into shipping containers. So there could be a classified location or locations anywhere that look like distribution centers for Walmart. And but instead of Walmart distribution centers, what's leaving is rocket launchers and rockets. The thing about it is, though, is we're in a world, it's not just rockets and AI and drones, it's rockets, AI, drones, and satellites. And so if you can imagine satellites that are imaging the Earth ever more frequently at ever higher resolution, you can just hit the rewind button on the planet, right? So your ability to, there was I believe now, declassified program that was used back in Afghanistan. I heard on a podcast a couple of years ago, and it was a big aha moment for me on the importance of space. There were, if you recall back in that conflict, there were a lot of American soldiers that were being wounded by improvised explosive devices that were being embedded in the roads and blow up a Humvee. Soldiers were losing their legs. They were coming back. Yeah. And it was a real problem because that's again the asymmetry. You can take a bunch of American soldiers and a Humvee with all the stuff, and you can take a $100 explosive thing and you can blow it up. So they built a capability that was effectively hundreds of very high resolution video cameras, and they put it on an aircraft and they just flew around in circles. And it would just dump the data down to the ground. And you could literally use this composite view of everything in Kabul, and you could find one of these events where you had a Humvee blow up, and then you could just, because it's a pervasive real-time view of what's going on, you could just rewind the videotape, and you could watch, look, at 11 a.m., some guy dug a hole in the road, and okay, where did he come from? Oh, he came from here. Okay, who are his friends? Where did they go? And you can literally just rewind the videotape until you root out. All it takes is one event, and you can root out. And they would just send guys and just kill them all, and then it stopped. Unsurprisingly, and it's that power. It's like magic. It's like how did they figure it out? It happened once, but now scale that up to the whole planet. Right. Yeah. And that has massive implications. But think about, back to your question, where are they making these rockets? If you can have satellites, this is exactly what national security, intelligence agencies are doing with satellites. They're trying to figure out where stuff is happening. And so the reason why Astra's rockets go in shipping containers and Astra's spaceports pack up into shipping containers is because shipping containers are shipping containers. There are hundreds of millions of shipping containers, and they're used everywhere. They're used in trains and container ships and trucks. And so I would say that no one else is doing this. And back to my original point, with infinite capital, no one else will be doing this in the next decade. So if this administration wants to make an impact on national security for this generation of humans on this planet, Astra is table stakes for that, because we've already built a system that operates this way. And I think we have to think about that, right? And we have thought about that.
Yeah. As nations treat space as the strategic military domain with such, I would say, incredible applications, right? As you just described one example, but there's many such examples of how this kind of geospatial intelligence capability, ability to use drones to strike across the other side of the world. As all of these applications develop and space is treated as the strategic military domain, how does that reconcile with something, Chris, you've mentioned, I think, in some of your earlier conversations, that you would advocate for a free space economy, right? So you have this economic potential of space, right, which could be incredible for humanity, which I think, much like you, I'm a believer that it will be. How do you reconcile these two almost different strains, right? One is strategic military, you want to protect it, you want to keep it close to you and your allies, and then the other is this incredible opportunity for humanity, right? Economically and otherwise.
Yeah, I reconcile this with this idea that what we're trying to do is put the internet in space, right? The internet can be used for good. It can be used for military purposes. It can be used for commerce. It can be used for bad. It is simply a mechanism that we as humans use to communicate and transact, right? And space is just a place, right? And I think our ability as a species to access a place where you can connect and observe, back to the analogy at the beginning of the podcast, it is the ultimate high ground. You can build a beautiful home and on the top of a mountain, and you can build a monastery, you can build a church, or you can build a castle. And I think this is the metaphor. Humans will human, and we're building a platform for humanity to express its hopes and dreams and aspirations. But it's also a place where conflicts will play out. And I'm simply focused on building the platform, and that's the vision of our company. We cannot be successful if the view is not that it is a platform that we are building, or we'll fail. And so I think that's the
way. Yeah. Is your sense that, I think you were trying to suggest, right, that European companies will use American or European companies for their launches? Is your sense that, given the geopolitics of our time, we're likely to see two almost parallel, in the world of the internet, there's a term called the splinternet, right? That the internet has almost split into two, like the China, Russia idea of a national internet, which is closed off almost to the outside when they want. Whereas I think the US and other countries have this idea of a global, open, interoperable internet. They're two very different visions, and they're almost coexisting, right? It's not that one precludes the other in a way. Is your sense that that's how the space ecosystem will also end up developing, given the geopolitics of our time? It'll be almost two different parallel space ecosystems developed both commercially and militarily?
I mean, let's pull this back again to another internet analogy, which is net neutrality, right? So, I mean, there was a big, over maybe it's 10 or 15 years ago, this idea that, should Comcast or AT&T or Verizon or one of my telecommunications companies prioritize internet traffic from their media company or someone else's? And laws were written about this in our country. Again, I get back to it isn't about two. It's not about the U.S. and Europe or China, the Western and Eastern. It's about humans. Well, human, right? And so I think back in the early days of the internet, and the internet is a network of networks, right? And the stronger the network, the strength of the network is a function of how many people connect, how many networks connect. It's a network of networks. And so the reason why the internet is reliable is because it is now millions of networks connected, right? And how do you connect a network? Well, you dig a hole in the ground and you lay a fiber optic cable, and you have a question, right? Do I connect to you? Well, you connecting to me means me connecting to you, which means my customers can talk to your customers. And back in the early days of the internet, this was largely done in a place called a meet me room, where the fiber, there'd be a router for AT&T and a router for Verizon, and they would say, it's good for you if I connect to your network, and it's good for you if you connect to my network, and they'll just plug a fiber optic cable between those two networks. In space, you don't even need a fiber optic cable; you just need a laser beam, and so we can now form incredibly dynamic networks that can be totally changed over time. So, to the extent that there's value in connectivity between this company and that company, or this country and that country, I can flip a switch. Now, if one country or if one company controls everything, and this is the case where SpaceX and Starlink, they're the first mover here, and so this isn't. I'm not judging them. It is. They've done an incredible job with the technology and the innovation to build Starlink, but they're first, right? And so now they're being criticized because of this. I think that's a bit unfair. But how do you make a much more stable environment? Well, you don't just have one company, you have a million companies, right? And the question people always ask me is, well, every country doesn't need 10,000 satellites. I totally agree. But every country could have 10 or 100 satellites, and then they could decide, do they talk to the country next door satellites and the country next door satellites? And in a lot of cases, if that answer is yes, then you can form an internet constellation with tens of thousands of satellites, but they're all owned and operated by the telecommunications companies in those countries. There's no no country lets another country own and operate its telecommunications infrastructure. This is only true in space. Why is it true in space? Well, because early days, it's really hard. So back to my future, we're enabling a platform that will enable every country to own and operate and control, including our rockets. So our rockets give you that sovereign access to space. It's only 100. There's 100 space agencies on Earth. You know how many can get to space? I think it's 7. So that means there's 93 countries that have space agencies that do not have rockets that they control. They have to go to another country to launch their satellites. So I see that as a huge opportunity. One of my OKRs is, how many countries have we launched from? I'd like to launch from 100 countries. And so that's fundamentally a different metric than SpaceX talks about, right? They talk about the number of launches, or actually they talk about the total mass to orbit. Yeah. So mass to orbit, they're going to win because Starship can put an enormous amount of mass on orbit. But number of launches or number of places we're launched from, they're different metrics that serve the economy differently and serve national security and other geopolitical ends differently.
And our current space treaties, like the Outer Space Treaty and all of them, now they've been around for decades. Is your sense that entire space governance piece, in terms of international treaties, space treaties, is that sufficient? Needs massive upgrades, updates, or it's not going to happen for some time until maybe a few years down the line? Where do you stand on that?
Yeah, I think these things need to evolve. I think if you don't evolve these frameworks, then you get distortions, right? I mean, and some of those distortions might be unintentionally positive, and some might be unintentionally negative. I think I cite one example, which is people talk about space debris. This is a big problem.
Yeah.
It can be a big problem, but many people are surprised when they learn that the vast majority of space debris isn't from satellites that died, that we left up in space. It's from 3 discrete events where nation states destroyed satellites on orbit to just prove that they could do it. We did it. China did it, right? Russia did it. And what that did is 99% of all the space debris that creates
those 3 events
was from those 3, and there is no law against that. So yeah, do I think that that's probably short? Yeah, we should figure, but then who's going to enforce that? So there's a tragedy, the tragedy of the commons kind of situation that is difficult. It's a little intractable, but one thing I like to always point out is the Earth does have a garbage collector, right? And it's called gravity. And if your satellites are flying very low and they die, and even if you lose control of them, they will re-enter pretty quickly in a very low orbit, in weeks or certainly months in a low orbit. The higher the orbit, there's an exponential increase in the amount of time that satellite remains in orbit. And fortunately, what I see happening is there's another more physics fun, which is it's also pretty interesting that if you are near a cell tower and you double your distance from the cell tower, your phone consumes 4 times as much power to get the same amount of information across that link. It's an inverse square law, right? So if a satellite is in a geosynchronous orbit, and which is tens of thousands of miles away from Earth, to get a certain amount of bandwidth and connection, there are orders of magnitude more power that you as a transmitter or they as a transmitter. So as a result, this is why Starlink is so powerful because it's in such a low orbit, right? And it means that you can have very high bandwidth with a very small antenna, and you can trade the size of the antennas against this equation as well, because it's a square law thing. So I guess the point is that it's better to have lots of small satellites in low Earth orbit because debris isn't as significant of a problem, and you also have much higher capacity.
Yeah. We've spent a lot of time, Chris, and this has been great talking about the geopolitics of space and the relationship between the government and defense departments and militaries and space companies. But let's now come to a little bit more of the, let's say, optimistic, fun part of space right now. As we were trying to say, the entire space economy has become so multidimensional, so many different applications coming up. Talk to me about what are some of those applications of this growing space capabilities that we are developing that you are most excited about.
I think I'm excited beyond just this idea that right now satellites all largely communicate using radio waves. I think that that is the way you do things. It's the only way it was possible for many decades. The thing about radio waves is when a satellite, say, is taking pictures up in space, it needs to beam that data back down. And companies that have been successful satellite operators, they have to invest in global ground station networks, where the more data they collect, the more when that satellite fills its cache up, it's basically got to dump all that data back to the ground so that it can actually make use of the data and can distribute the data to customers. I think that we are now entering an era where we can move from radio waves to light. And so we're going to see, and light is great because you don't need licenses. It's not jammable. It's not detectable. It's lower power. It's all sorts of great benefits of it. Doesn't interfere with anything. And so we're going to enter an era where being able to connect a satellite to a network in space optically is going to drive a whole new wave of like an optical space internet. So I'm really excited about this. We're working on some stuff in this area to really accelerate the transition from radio to light in space, from radio to optical. And so I'm super excited about that. I think that also satellites and drones. So, the more drones we see, if you're flying a high altitude drone platform and you point up, you can get to a satellite. So connectivity between satellites and aircraft and drones is going to be pretty exciting. And that's also unjammable. So that's exciting. I think that I'm really excited to see where this project we're doing, putting drones and rockets together. So I call this framework RAIDS, rockets, AI, drones, and satellites. So the combination of the intelligence, our rocket is an autonomous vehicle. It's but combining all of that, I think could have a significant impact on the way we think about the way we spend money in the military, right? I mean, a single aircraft carrier, I could place millions of drones and thousands of rockets in hundreds of locations, right? And that would transform the entire military for the price of one aircraft carrier. So call your senator, call your congressman, send some money to Astra, and Anduril, and a few of the other companies. So I think that's exciting. I also see companies doing things like collecting power in space. I think that's pretty exciting. I think if I go well into the future, right? So say Astra is now $1 trillion company, like Apple and Nvidia, and we're now as a giant spaceship-sized campus here in Silicon Valley. What does that look like? Well, I think that if you imagine Earth as a living organism, we have an enormous amount of energy that hits the planet. We can capture that energy. We can send it using lasers, microwaves around, and we can beam it back down through the atmosphere. We can basically, what is the sum total of all energy companies worth? Probably a lot more than $1 trillion on Earth. It rained for a few years in California. What did that do? It filled up our reservoirs. It allows farmers to grow crops. I think there's an opportunity to using our models and our sensors better understand and model weather, we could make it rain again if we needed to. So what if we could end famine and drought in various places in the world by taking a bit more control over just collecting some water in the atmosphere and dropping it, and just using our Earth's systems. A lot of people think about this kind of stuff and it scares them. We're doing it right now, but in a very clumsy way. We're affecting the environment. And increasingly, with better sensors in Earth orbit, we'll be able to understand these patterns, and we'll be able to maybe prevent hurricanes from destroying coastal areas. So I think that's what does that look like? What is improving the productivity of our crop yields by 50% globally? What's that worth? So you just keep looking at that stuff, and it's connecting the other 3 billion people to the internet on Earth. What's that? I mean, space is an incredible opportunity, and we're building a company that I think will be around for a long time to tackle some of these challenges.
You've spoken a lot, Chris, about, and we've spoken a lot about the applications that governments and businesses are likely to see from space. But let's say in the next 2 to 4 years, what are some of the biggest consumer applications? So for the lay people listening to this podcast as well, right, who are not sitting in, either the military domain or the geopolitical domains that we've been discussing, or even businesses that are leveraging geospatial intelligence heavily today already. For other consumers in this world, what are those in the next, let's say, short term, 2-3 years? What are some of the biggest applications you anticipate that will be influencing or shaping the lives and productivity of consumers around the world?
Yeah, I think
derived from these space capabilities.
The first thing that I think you'll see is your cell phone will be able to take calls from anywhere and send text messages from anywhere. We're already starting to see that. I have a Starlink number through T-Mobile on my iPhone. Costs $10 a month or something like that. But I was in the middle of the Grand Canyon, and there were no cellular towers for 50 miles, and I could pull my phone out. Again, just a standard off-the-shelf iPhone can connect directly to a satellite overhead. And so that's something that's accessible to all U.S. and probably in the future other countries in the world. I was sad to see it not work in Europe and in various other places, but it's certainly possible to do that. And I think that's probably the biggest short-term thing is we have customers now working with large carriers to provide connectivity globally using existing handsets. And what's exciting about that is back to scale is what makes innovation matter. There are a lot of cell phones. And if you can take an unmodified cell phone and you can allow a consumer to use it, that might not otherwise have cellular access, it'll open up the internet, AI, ChatGPT. I mean, imagine being able to connect to ChatGPT. Billions of people can connect to it anywhere on Earth. I mean, I think there'll be a huge increase in global productivity when that happens.
Yeah. But other than communication connectivity, do you see other applications entering the sort of the mainstream use from a consumer standpoint in the next 2, 3, 4 years? Or not?
We'll see if some of these companies launch consumer-focused products around Earth observation. It hasn't happened yet, right? I mean, I don't have an app on my iPhone that benefits directly from Earth observation. We might see more accurate.
And that's because the costs are still too high?
I think it's just because we haven't gotten there yet. I can imagine lots of these types of products that I just haven't seen yet, and I could see companies creating. You can see my more precise GPS and location tracking. There are companies working on much higher resolution GPS alternatives. Though the combination of GPS and cellular triangulation is pretty good. Like you can usually triangulate a phone within a few feet using especially Wi-Fi as well. So I think, but there, you'll see some advancements there for that. I think probably the other thing is I look at cars. You're going to see a car generally drives on a road with a clear view of the sky, and more ubiquitous satellite connectivity. Cars are constantly collecting data. They're constantly training models on road conditions. I think as the price point of some of these satellite systems comes down, every car will effectively be a Wi-Fi hotspots, cell tower, however you want to look at it. And so, companies like Tesla are very well positioned to be early adopters of this because their cars are constantly pulling, software updates and taking data they're collecting and sending it back. And I think satellites could be a pretty efficient way to do that, given cars are you're always charging them up and they're always driving around where they have a clear view of the sky. It's about the cost of that module relative to the BOM cost of the car right now. But that as that cost comes down, you're going to start to see more intelligent cars take advantage of, real-time updates from other cars on road conditions and things like that.
Yeah, let's now move, to the last section. Really, I want to talk to you about, which has been your journey and reflections from that journey. Right? I know you've said that you're just getting started, but I think it's never too late to reflect back. So I don't mean to make you sound like a veteran here, though you are a veteran. But as you said, you're just getting started, and there's exciting times ahead. But of your time, let's say at NASA and the other startup you did, and then now Astra, what was your hardest moment as a leader, as a CEO?
Yeah, I think it is really humbling how hard this stuff is. And when we had our first orbital launch that was successful, we were boldly both continuing to launch that third generation rocket while working on developing the fourth generation rocket, while working on acquiring a satellite propulsion company, while working on acquiring some other companies. And, we really bit off a lot there. And I think I underestimated, just how hard it is to make this stuff work at scale, right? And you hear people talk about just the need for focus until you make the first thing work, don't go work on the second thing. And I really thought we'd crack the rockets. And really, fortunately, the market spoke and it said, well, your rocket is just too small. And we didn't put more resources into it. We made a decision very quickly to stop after the last flight of a NASA mission that didn't succeed. Within 2 weeks of that, internally, I had stopped the program because I realized that we had to put all the resources that we had as a company into what we call Rocket 4. And even then, to do it right, it was going to be really hard. And then we had a very successful product in the market, our satellite propulsion systems. We sold those to over a dozen different big companies. And the thing that I learned about that was having all these different product variations and a lot of them going to big national security, big defense satellites, the near bottomless resources that you can invest to satisfy a government prime. And we had multiple government primes that were the end customers for these systems. And so the call of just give me more resources and we'll figure it out for years. And so I think that all told, we lost $100 million just trying to do the engineering to make sure all of these propulsion systems could be shipped, and learned a lot about that. I mean, I think that in retrospect, the more we could have just sold one product and put all of our energy on making that one product great, and then let the customers figure out how to integrate it into their satellite buses, that would have been a better strategy for us back then. So I was humbled by just how difficult it was to do the systems engineering and mission assurance to meet all the requirements for some of these programs. And so I'm very humbled. I'm really happy that the team didn't give up and a lot of our shareholders didn't give up. I really regret not being able to make it work as a public company. The costs associated with remaining a public company were staggering, and we were facing bankruptcy. And it was one of the hardest things that I did was saving the company from bankruptcy, and I did it because so many people were relying on our products, and because I knew the Defense Department didn't have an alternative to this rocket, and there are no rocket company. If you don't make it work, it dies. People aren't going to take our engines and our rocket and do anything with it. Look at Virgin Orbit, right? No one used any of that stuff. They bought it, maybe they'll use the test sites. But we put so much energy into this that we needed to make it work. And it was one of the riskiest, hardest, most challenging things to navigate, both that transaction itself with the market and our board, and also continuing to keep the company going. And it's a great testament to our team. My leadership team stuck with me throughout the entire time, and I'm just so grateful for them. And so many of our employees just stuck with the project. We've always had over 100 employees working on this at all times. There was not a single day where everyone didn't come in and work to make the company work. And that's, I'm just so humbled by that as well.
No, I think that's, it's, baptism of fire, you can call it, real resilience gets built through these times, I think, in the journey of a company. And of course, I think it's testament to your leadership and your team that you've, ridden the highs and the lows and are back at taking a crack at it again. Tell me, for entrepreneurs or budding entrepreneurs who might be listening, Chris, especially those interested in being entrepreneurs in space, what advice do you have for them? One. And second, what spaces do you find are the most interesting, those white spaces that you'd say, hey, listen, to budding entrepreneurs, listen, go check out these white spaces?
Yeah, I think that it's never been a more exciting time to be an entrepreneur in space, literally today. And so many companies working on so many different projects have just raised so much capital, right? If you look in the last few weeks, few months, few quarters, there was a wave that came through that peaked in 2021, and then there was a real shift where it was almost impossible to raise capital for these projects, and it was really scary. We were public during that time, so our stock reflected that, along with the stocks of other companies. Companies that had gone out at $10 a share were forced, either to do reverse splits, which is almost always is the end, or trade in the $1 to $2 range. Some of them still haven't recovered from that, or in the kind of $3-4 range right now. And they're great companies. But that 2021 wave, there's been a new wave in 2025, and many tens of billions of dollars have been invested in dozens of great companies. And so as an entrepreneur, you could start a company, or you could join one of these companies. And if you're a young entrepreneur, I would recommend you just go and try to get involved in one of these companies and just take on as much as you can. Just do just ask to help out, and help out as many people in the companies you can. Learn as much as you can. It's about embed yourself in the smallest company you can stomach, hopefully that has good investors and a great founder team, and just go and help. Don't worry about your salary. Don't worry about the equity. Just learn, and that's how you figure it out.
Yeah, and any particular white spaces you think that that are there, that you feel like now, that given the state of the ecosystem, are now ready for more entrepreneurs to go into? Let me ask it differently. If you were starting out today in space, completely afresh, what sectors or sort of spaces would you be looking at?
Yeah, it's a great question. Like, if I were to just completely start over today, I would literally go build exactly what I'm building right now.
That's a good answer.
I really would. It's like, and I think to some degree our vision has never changed, and the path there. We took, the only thing that we did wrong, I think, was when we went public, we attempted to do too much too quickly. So we attempted to go buy all the pieces all at once. And I think had we just, for example, focused on the rocket until the rocket worked, kept all the cash, we probably could have rolled through this 4-year period between 21 and 25.
When the market comes up.
But we spent cash on the propulsion business. Now, in retrospect, I mean, it's a butterfly effect. I don't know what that would have done. I mean,
What triggers what? No, that's true.
having the
That's
propulsion business now is great because it creates cash flow for the company, and it kept the public company even going. So it served both the public company and having some exit for the shareholders. It's tricky, yeah. So I mean, I don't have any regrets, other than things. A lot of things outside of my control. The things in my control were just maybe trying to do everything that I said I was going to do. When we went public and I wrote letters to shareholders and I said, this is what we're going to go do. Maybe that was too much, and I regret not being a little bit more patient and disciplined about how quickly we tried to get it done.
Yeah. No, this has been fascinating, Chris. Thanks for sharing both sort of the big picture about where things are headed, but also your personal journey and your leadership lessons, and of course the tough times that you've managed to face and overcome. So best of luck, of course, for the future. We end every podcast with two quick questions, Chris. One is for people interested in the kinds of topics we've been discussing, book or two that you would recommend. And second is a couple of podcast guests you recommend we speak to.
Ooh. Oh, interesting. So first question again is?
Books, and second is podcast guests.
Yeah, I guess...
or it could be something else. It doesn't have to be a book, but it could be something else. It could be a Substack today or
Yeah, I guess a few of my favorites that I think have a big impact on how we think about things here that I always point people to are Measure What Matters, which John Doerr
That's right.
authored. The idea of objectives and key results that are measurable, that's how we run things here. So our company has 5-year, 1-year, quarterly OKRs. We have an offsite with every leader where we align every team. Every team has OKRs, and they all link using language models now. It's very easy to ensure that every objective and key result from every team can be thought of as a whole system of accountability to ensure that the company is making progress. It's how, and I'm so excited to have all the time back to basically lead the company versus, lead the company through the challenges that we had. And I think that's one. I would say another one, I'm a huge believer in Scrum. So there's a book called Doing Twice the Work in Half the Time, and it lays out principles that we use daily on just making sure you are focused on the velocity of your efforts. So I think John's book really focuses on strategy and how you align strategy across the whole company. Yeah. This other book, I think Jeff and JJ Sutherland are the authors, talks about execution, talks about making sure that I'm pretty much aware of what every employee in the building is doing right now, and I am aware of everything that is creating an impediment for everyone. Every purchase order that needs to be approved, every machine that's out of calibration. So this is a framework where these impediments are escalated daily, and everyone is tracking this stuff. We're looking at velocities, and it allows you to instrument things. So those are two that I like a lot.
Podcast guests, those are great recommendations. Even I have used John's book a lot.
That's a good one.
What Matters. So I'm a believer right alongside you.
Your key result is number of size of your audience, I assume, is a big one.
That's right. And then what about podcast guests you recommend?
Wow, that's a good one. And I think to kind of stay focused on this national security and defense angle, I'd love to always interested in what Palmer Luckey and the guys, maybe Trey Stevens over at Anduril, how they're thinking about things, get an update on things from them. Let's see. One of my mentors who I think I've learned more from than almost anyone is Pete Warden, who's kind of featured in the books and the films that have been done on our journey. But Pete's probably one of the most philosophical and thoughtful visionaries in space right now. And I just, I would really enjoy listening to his thoughts.
No, great. Thanks so much for these recommendations. We look them up and hopefully folks pick up some of the books that you've mentioned as well. Thanks again for sharing so much of your insights and your journey with us, Chris. It's been a pleasure having you. And of course, best of luck with all your endeavors.
Anirudh, thank you so much. And I'm excited to hopefully hear those folks join your podcast as well and listen to their thoughts.
And I look forward, as Katie and I were discussing right before, I look forward to coming and seeing Rocket 4 sometime.
Absolutely. I'd love to have you. Thanks.
Take care.